Problem 103, we're taking a look at some logarithm properties. So problem A, log of x plus log of x plus 21. Both those logarithms have the same base. If it's not written, it's a base of 2, or 10 rather, I'm sorry. And that equals 2. So I can now write that as one logarithm by multiplying these two things together. So I will get x times x plus 21 equals 2. Distributing this right here gives me x squared plus 21x. So now I have the log of that equals 2. Since this is a base of 10, I now can go ahead and write this as in exponential form. So 10 is my base to the second equals x squared plus 21x, which is 100 equals x squared plus 21x. This is now a quadratic that I need to solve. So I'm going to go through and set it equal to 0. I have 0 equals x squared plus 21x minus 100. This does factor. It's going to factor into x plus 25 and x minus 4. Zero product property, x will equal negative 25 and x will equal positive 4. Now, looking back at the original problem, both of these right here, if I substitute negative 25 in, I cannot have log of negative 25. I also, for this one, cannot have log of, when I simplify it, negative 4. Therefore, this is extraneous, and my answer is 4. All right, going to problem B. I have a 2 out front. So what that means is I can take that 2 out front, and I can put it back as an exponent. So I will have then log base 4 of x squared minus log base 4 of 3 equals 2. Since I have the same base of my logarithms, I can combine these two. But now since it's a subtraction problem, instead of multiplying like I did in the last one, I will divide them. So I will write this as one logarithm. It will be log base 4 of x squared over 3 equals 2. I'm again, just like in the last problem, switching this to its exponential equivalent. So base of 4, exponent of 2, so 4 squared equals this right here, x squared over 3. 4 squared is 16, and I'm going to multiply both sides by 3 to get rid of that. So now I will have 3 times 16, which is going to be 48 equals x squared. Now I'm going to simplify that. So square root of both sides, I get the plus and minus over here. So x will equal plus or minus square root of 48. Square root of 48, I can simplify that down. It is 16 times 3, that's how we got that number. 16 being the perfect square. So it is x equals plus or minus 4 square roots of 3. Now, again, just like the last one, checking for extraneous. So if I go through and put the negative 1 in to that right there, I will no longer have an answer. So I cannot have this negative possibility. So the answer here is just x equals the positive 4 square roots of 3. Looking at problem C. Base of 2, base of 2. So now I'm going to go through again and write it as one logarithm. log base of 2, and I'm going to divide 9x plus 5 over x squared minus 1 equals 2. So now I'm going to get writing it as its exponential equivalent. 2 squared equals 9x plus 5 over x squared minus 1, which is 4 equals 9x plus 5 over x squared minus 1. I want to get this out of the denominator, so I'm going to multiply both sides by x squared minus 1. So, or cross multiply, you could think of it as cross multiplying as well. So I'm going to get 4x squared minus 4 equals 9x plus 5. So now I have my quadratic. I need to set it equal to 0. Subtract the 9x and subtract the 5, and I have a 4x squared minus 9x minus 9 equals 0. So from here, I can try solving it by factoring. I could use quadratic formula. Probably don't want to use completing the square on this one. I'm just going to go through and use the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So I have 9 plus or minus the square root of 81 plus 144 over 8. So that's going to end up being here 9 plus or minus the square root of 225 over 8, which is 9 plus or minus 15 over 8. One quick thing before I go on, because this is a perfect square, that means that I could have actually went through and factored this, so factoring would have worked out. That's okay if we don't need to factor it. Now I'm going to switch to 2 separate problems. I'm going to go through and I'm going to put in 9 plus 15 over 8 and 9 minus 15 over 8. When I add them, I get 24 over 8, which is 3. When I subtract them, I get negative 6 over 8, which is a negative 3/4. So my solutions now are 3 and negative 3/4. Again, thinking about extraneous roots. So when I put a negative in for this one, it's okay. Actually, no, it's not, because I square it and I subtract 1, it's still going to be negative. When I put it in here, 9 times a negative 3/4, it's going to be a negative 27/4. And then add 5, I'm going to be getting negative values, so this one is extraneous. So again, the only solution then is 3. And the last problem. Again, same base. This time I'm just like in problem A, I'm adding, so I will multiply. So I have log base 7 of, and if I quick go through and do x plus 1 and x minus 5, I'll get x squared, x negative 5x, and negative 5. So it will be x squared minus 4x minus 5 equals 1. Switching it to its exponential, 7 to the first, which is just 7. Setting it equal to 0, so subtracting the 7 from both sides. And now factoring. This factors pretty easily into x minus 6 times x plus 2. Zero product property gives me 0, or x equals positive 6, negative 2. Negative does not work in either of these. It is extraneous. X equals 6 is the solution. Hope that helps.